good morning. As you can see, I'm the third professor in this course, or the third actor on the stage, depending on you. Actually, well, this is the title of my lesson today, and you can see my name. Probably some of you already know me, given your past experience in the BS degree courses. Maybe some of you not. Well, actually this year my last name is, well, particular in this course, since occasionally it is shared by one of the students here in this room, and she happens to be my daughter. So this is a source of conflict of interest that will be dealt by me in the following way. I will be out of the exam procedure, fully out. Of course, you have to trust me and the other professor, but I will be out until the conflict of interest is removed. Okay? So the direct consequence for you probably, the first consequence number one, I'm probably not in the list of your enemies. So, which turns out that probably I'm a little bit more on your side, probably. The second consequence could be, well, forget about my lessons. If I'm not on the exams, what are you doing here? Maybe just listen to the lectures of other professors. Probably one professor is already done in terms of lessons, and the other is Professor Quare, who is sharing with me the Windows part. If I were you, I would not bet, on the null importance of being here, since I feel that probably I can give you some contributions, or some positive contribution, in a better understanding of the Windows part, and maybe some more general part. It turns out that I'm the professor in the parallel course, the Italian course, for what is being taught to you here by Professor Laface. And I basically share and know a little bit of the topics that have been introduced by you. So, of course, the other solution would have been to remove myself fully from the course, but I had to find a replacement, which it was not possible for several reasons. But, I mean, here, let's move to technical stuff that is probably better in this framework. What am I doing here? We are trying to cover with Professor Quare a part that is traditionally the Windows, the Microsoft part of the course, which doesn't mean at all that I'm affiliated to Microsoft or we are taking money from Microsoft at all. Traditionally, the word is split in Microsoft Windows supporters and Linux, free open source software supporters. Maybe some of among you also you are somehow split, and I would bet that you are more for Linux, at least philosophically, and probably better experienced, at least from a practical point of view, on using Windows. But sooner or later, will have to decide, depending on you, who is going to hire you and pay you, if you prefer to be a programmer in Windows, in Apple, in Google, in whatever. And at least from my understanding, you must be prepared to be a good programmer wherever it turns out to be the good solution for you. So here we simply try to cover two different views of something that is similar, because if you think about the internal details of Linux, Unix operating systems and Microsoft operating systems, they look so different from the outside, and they are pretty much close on the inside. But this is probably not now our best worst problem. Our problem here is basically the following. If you look at the documentation of Microsoft Win32 and Microsoft System Programming Interface, so Windows Programming Interface, typically you should do something like Google whatever, create file, write file, whatever keyword, and then Win32. You will be redirected to something that looks like docs.microsoft.com. Once upon a time it was MSDN. But typically you will be redirected to a Microsoft.com site where you can find pretty much complete and useful documentation, including examples, application examples, which is good. So, we do not provide direct view on this, but as a last chance, when you don't know what to do, please look at the Google something and try to filter out. Stack Overflow is pretty much good, but typically does not provide the original documentation explanation. So it's more on the side of who has problems and try practically to solve the problems. The best solution is to go to Microsoft.com. And you know that you have the reference manual of whatever. And so the difficulty is understanding the global picture, starting from pretty much diverse and fragmented information. Okay, so this is the framework. On the website, you will find, at least on my slot in the website of this course, you will find some slides. I did not provide a big effort in preparing slides. They are basically taken from the author of the book that we are using, and the book that we are using is J.M. Hart, Windows System Programming, 4th edition. Well, you can buy it, but if you Google J.M. Hart, Windows System Programming, you will easily find the PDF that I'm using. Okay, so this is pretty much easy. And I don't think that the author put a big effort in protecting this, as the author is, I don't know, probably was, now it is not anymore, but was a Microsoft employee. So the best interest of the author was to make this pretty much widespread. And since also the business model of Microsoft has moved from simply selling PC software to cloud services, and right now basically Microsoft is making money from Office and from cloud services, not on Windows directly. So Microsoft is pretty much interested to developing and finding software developers for Microsoft platforms. So this is not a secret. So this book is good, and it is a good introduction, discussion on what we're talking about. If you look at the index basically, you can see that beyond the first chapter, second and third chapters are what Professor Quare has been teaching you over the last few lessons. So chapter 2 and chapter 3. Chapter 3 are on file and directory management, which is probably easy if I say it this way, but the problem here is, well, Unicode. So the problem in this kind of framework is becoming familiar with something that is constraining you to change a bunch of names and typical calls that you could be familiar with working in C to something that looks like not too far but slightly different. And understanding whether you are simply looking to standard charts, characters, 1-byte characters, which is something that in the Linux world is given. So typically you will always have standard characters and array of chars, pointed to chars or whatever. Whereas here, for Unicode is interesting because if you look more, if you go more on the application and user interface side, and you develop code for mailers, for web browsers, or so on and so forth, you will have to deal with languages and with encoding of text that needs Unicode. Practically speaking, you have to understand whether you use chars, wide chars, W chars, so T chars that are basically reconfigurable. They are both of them depending on you defining or undefining Unicode. In the top of your first file, first.h, or better in the build setting for your component. Okay, so this is the framework. But essentially, in those two chapters, you should have learned, and this is what you are expected to do in the lab these couple of weeks, understanding how to open, close, read, write files, share files, and maybe also opening directories, traversing directories, creating, deleting, copying, doing whatever on files. Okay, this is something that, if you look at it from far, as a couple of main difficulties for you that are the following. First, you have to learn a bunch of names of functions and whatever can be done in dozens of different ways. Fortunately, we are not typically, we are not in the exam so strict in evaluating the right naming and or order of parameters, but we more, at least at the exam, look at the ability to write a function that does something with given parameters. If you omit one parameter that is maybe not meaningful, or you swap the order, or you slightly change the name because you don't remember exactly, this is the same. Typically, any kind of programmer, software developer will develop software having, well, at my time, having a book or something to copy now, having a language sensitive or editor that suggests completes whatever you're writing, and so corrects. So, it turns out that we don't expect from a skilled programmer to know everything. And part of the lessons you're attending are teaching you everything, a list of everything that can be done in Windows. And so maybe the effort, and what I will be trying to do is try to filter out and to tell you what is important, what is less, and provide you examples. So I will not assist you in the labs, but in the lessons I will be using a mix. Well, let me see if, okay. Slide. Operation and then coming back. Okay. Okay, it works. So, I will mix teaching something new and showing you examples today as well. Second, the problem with Windows is that if you look at programs written in the standard Unix, Linux environment and Windows, you may ask yourself, but is this the same language? Because in Linux you always explicitly see pointers, so the stars. Here, no pointers, or at least very little use of pointers. But you see many types, so there is an abuse of type defs in .h files, because every kind of things we are using as being renamed to a new type for a simple reason. At a given point in the Microsoft history, they hired a set of software engineers coming from DEC, Digital Equipment Corporation, who wrote the Microsoft NT and the rest of the operating systems, and those kind of engineers prefer writing things in a certain way. So I like double word instead of integer, because in my thinking this is better. So you will simply have to look at the long list of Microsoft data types that has been provided to you by Professor Quare, where you see a long list alphabetically sorted of types in Microsoft. You don't need to learn all of them. You simply need to understand what a handle is, what a double word, what a pointer that typically starts with P. So try to understand or to figure out a technique to understand types, and to maybe in Visual Studio just put the mouse on a type and see what it is redirected or type def to. So this is what it is expected from. Okay, so given that, let me suggest you another thing. I have published related to this book. The slides I'm using are basically a slide modification of the slide provided by the author of this book. And I'm not going to modify them furthermore. So you will sometimes find details that I'm skipping or simply saying this doesn't matter too much. And I will be using examples from this book. I have published 2 zip files. One has been uploaded just this morning. Because I feel that there are slight differences, and some programs are interested even in the previous version of this book that was edition 3. So, for instance, if you go to the edition 3 version of this book that is here, edition 3, you can find that in chapter 2 there is an ASCII to Unicode example program that is not too far from something that may be interesting for you for the labs. So there is an example of program, ASCII to Unicode.c. I will be using Emacs sometimes simply because it's at least in my experience, easy to use, language sensitive, and I like buffering and simply being able to zoom in and out in size. But I will be using as well sometimes Visual Studio just to visualize. Here, I'm not running, I'm just showing you programs. So if you look at this program, or programs in this particular directories, if you can see examples split by chapters, and so if you have the book, you can have the reference chapter. They are the examples taken from the book or related to the book or cited in the book. You have source codes, you have an include directory, and the author had put an everything.h file that includes whatever is needed. And basically, if you look at the directories here called, there are a few directory usage here that can be meaningful. There are directories here called include. In the include directory you can find, for example, where is everything and something else. You have here project 6 and 7. Here, just let me say that Microsoft software is a dynamic entity in the sense that here we are basically teaching something that was true and published a few years ago, where a few may be a little less or more than 10 years. If you want the latest releases, they are available on the Microsoft side. It is relatively stable, and one of the policies of Microsoft has always been the following. I need to sell and produce something where old code, where old can mean 20 years ago, can still run. So there is the policy of the so-called legacy code. Legacy means something that was written time ago and maybe is not yet supported. Yeah, they want to support that. with the exception of what has been explicitly declared not supported anymore because they want you to buy something else. Okay, so this is something that sometimes you will see also in the slides mentions to something that was Windows NT, Windows 2000, or something like that, that maybe is old story for you. Now we are basically at Windows 10, Windows 10, Windows 9, Windows 8. And it is already available since a few years. It has been available for a few years now. Okay, so story, and maybe something has been updated, has been corrected, has been patched. So, and also Visual Studio, you will have several different versions, and each one has a different framing and or windowing appearance. So basically, you need to be prepared to look where is debug, where is build, and something, and where are options. This is what you should know. How can I build a project? Now here you have project. The interesting story is that if you come in here, you have a list of directories for single files, and you find directly the projects. And if you look at VC project, double click on that, and you have Visual Studio. Everything already is set up for running the program, which can be pretty much interesting if you want to run those programs. The other possibility is start from scratch, open, create a file, and include Windows.h, include whatever is needed, and you do what you are doing or already doing in the labs and by yourself. Okay? So this is how it works. Here, my suggestion is take a look. I will not work on this, but take a look at this file that is ASCII to Unicode, because you will find ASCII to Unicode file containing just a function that receives two file names, input file name, output file name, that are long pointers to constant strings. T-strings means generic strings. It's up to you to decide if you want this string be a wide character, so Unicode, or a standard character string. Given those two strings, this program opens the files for one for reading, the other for writing, and basically one file strings are for file names. But one file input is considered standard characters. The output file is wide characters. So what you will have if you read 100 bytes, that means characters from the first file, it will write 200 bytes on the second file, because for each one in the first you have two bytes in the second. Take a look at this file, because it is a good example of usage of file open, file close, file read, write, and so on. So this is just a function, whereas the main file is contained in, let me go back a little bit. The main file is chapter 2 is A2U. A2U.c is the main. Tmain, where Tmain simply means, well, I'm the main that could be either the standard main or the main receiving RV as wide characters. So, so this is the general purpose, at least in the Microsoft interpretation of the Microsoft environment. It can be either a main receiving standard strings or wide Unicode strings. So basically you have simply, the best way to learn is a new environment is look at the reference manual, look at the slide of professors, look at the book, and study whatever is written, but sooner or later, and I suggest sooner, take a look at the examples. Because the examples are what help you understanding concrete stuff with respect to something that is too much abstract and you don't understand where you're going. Okay, so this is something I'm suggesting to you. Second, now we are going and we are moving to another
example that exists in the two frameworks, so I'm taking it from edition 4, so it is explained in the book. Chapter, if I remember correctly, chapter 5 or 6, let me just, chapter 6, the one on processes, because what I'm trying to do here is processes. You look at grep multi-process. So this is the application that we are using right now, and basically this grep multi-process is doing the following. So I hope you know what grep is. Grep is a Unix-like command, and the author of this Microsoft Windows book is providing many examples of programs, C programs, written by himself. So he wrote many programs that are basically implementing something that is typically provided by the text user interface in Unix. So you will find grep cp, that means copy a file, and concatenate, that is usually the type. So take the content of a file and show the content of the text file on video screen. So you will have several of those commands. So grep typically means that here I'm in the include directory where I have many files that are the include files for this library provided by Art. And so here I can, for example, search, grep means search a word in the file. So you can search, for example, grep include in, for example, p thread p p.h, and you can see that pthread.h, you see here are the lines in the file that have this include keyword. But you can also look at include or grep maximum weight in .h. No, it's not present. You can look for instance, what I saw here, include in a list of files in, for instance, client server, job management, and if you grep a string in a set of multiple files, you will have the list of the files that just one of them include. If you look at typedef, for instance, you will see that typedef is included in, is present in many files, and so you will have a prefix, name of the file, column, then you have the string that where the string, the search string appears. If you want to search something that is included blanks, you should add string by double quote. So, for example, struct something, I don't know, struct p, for example, p. You can search this way. All right? So please try to look at the documentation. This is one of the files of commands that probably with Professor Laface and Unix you have been using. Here we see an implementation of grep where the idea is the following. Do you want to search on 3 files? Yes. Let's start 3 processes, each one grepping on that file. So the example we can see is the following. Grep multiprocess is the following. You can see and you can read a list of commands initially that basically declare what the program is doing. The main is doing the following. We'll come on this later on, but basically the main is doing the following. At a certain moment, once the main knows how many processes are required, take a look at the fact that argc, number of arguments, includes the name of the executable and here the search string. So if you have 5 arguments, it means that the file to be searched are 3.
So this is the reason for argc -2. So suppose we want to search 10 files, which means argc equal 12. So for 10 times, so iteratively, we will here basically create process for doing something. So the idea is we want to practice with creating a process. What does it mean creating a process? And then, after doing that, get an exit code of the process and or waiting for termination of the process. So, in order to explain that, let's go for a while to the boring part of my lesson, that is, we have some slides to show. So, and if we want to take a look at the slides, let's see here, on my name, we are talking about Windows processes and understanding what Windows processes are and why are they meaningful and what's the difference between Windows processes and, if you want to understand, and Unix, Linux processes. Okay, let me skip this. We will have 5 parts. I will probably move quickly to an advanced part here. So, first of all, what are processes and threads? Here, maybe you should already know this because since, well, based on the first part of the course, so the part taught you by Professor Laface, and from operating system courses that you may have attended in the in your BS courses, so you should know what a process is, but we can review something. By the way, please, whatever you feel important to ask, feel free to ask and interrupt me. Basically, my intention here, I don't want here, since I have some lessons, from here to the end of the course, I will spend approximately 18 hours or so with you. So, I don't want to increase the amount of things that I'm teaching you, so I want to spend my time half and half, teaching something and showing examples, so I can have time to answer questions. So if you raise your hand and answer a question, I can try to simply help you understand. So, let's talk about processes. What is a process? Well, so, a process, you may know, since what you already have studied, that a process essentially is a user, so not kernel entity, and it is a program under execution. So, a process is, you have an executable file, you have something to run, double click, and the process is that program with data, with concrete data, which means something in memory and something in the registers, so in the CPU. So, the process is a program executing in the CPU and or in other state, waiting for execution, waiting for I/O or something. And the process, I guess, since you have studied what logic addresses, virtual memory is, a process, for the sake of convenience, is characterized by the so-called address space. The address space is, I am a process, I like to see whatever is in memory for me as something private, starting from 0 and going as a contiguous set of addresses to a maximum value. And I don't care being on a CPU where I share CPU and whatever other resources, including memory with other processes. Fragmented or not, paged or not, virtual address spaces are my identity. So, a process is primarily identified by memory, not only by registers. Because data dynamically stand in memory and in registers, plus something on disk, so on mass storage. So, each process contains one or more threads. You are familiar, you need to be familiar with threads since you have done many. So part of this course is dedicated to concurrent programming. So threads processes are the main ingredients of concurrent programming. So a Windows thread is the basic executable unit. I don't want to go into the details of these aspects, but traditionally and historically, Windows was an operating system that started with the threads in the middle. So the CPU scheduler dealt with scheduling threads. Unix started with as a process-based operating systems that, along with time, supported and now supports threads. Threads were first introduced by pthreads as something external, then they become basically some native objects in Linux and Unix as well. So, threads are basically executable unit, and a process can basically create new threads or create other processes. The big difference between Windows and Unix in this context is how processes are created. So basically, I don't want to make it very, secret. In Linux, Unix, you have fork. So fork is one of the preferred way of detaching processes, which means what? It means that the software engineer, the programmer, is writing a single program that is behaving both as a parent and as a child. So in the same file, or in different file, but in the same executable, you have both behaviors. In Windows, they prefer something different. Whenever you generate a process, typically you say, I'm executable A, I will start a process executing executable B. Two different entities. It can be done also in Linux, of course. You have you have other ways to generate processes in Linux, Unix. But fork is one of the main, initial strategies to do concurrent programming in Linux. Okay, so in this context, it is different. So, what is a Windows process? Let me go a few slides ahead and then go back. A process is depicted here. A process is something where, here on the top, on the top 2/3 of the picture, you can see whatever is shared by all threads in a process. And whatever is shared means that a process and all threads in this process have in common, have code, which means the instruction. The advantage of writing threads is that multiple threads in a process share the same function, the same set of instructions. Two threads means just once you have the code. Okay? Then, global variables. And this is the main reason why, at least initially, threads are a good way of doing concurrent programming, since they can basically share global variables. Now there is a debate that can last forever among programmers on the practice, good or bad, of using global variables. I personally prefer not using or not abusing of global variables. Sometimes you cannot, work without global variables. But global variables are something that is sort of a mess on the table and whatever is visible to everybody. And whereas local variables are a much more ordered way of, a modular way of working. Okay, so beyond that, process heap. What does it mean that process heap is here? Process heap is where malloc and free are working. So, please, take a note. This will be the third topic of my set of lessons, memory. The process heap means the following. Whenever you call malloc, take care of the fact that the pool of memory available memory for malloc is shared by threads in a given process. So, when I call a big malloc, I potentially steal memory from other processes that, other threads that could try to do malware. So it is my global interest to free as soon as I'm able to free. Okay? Then, process resources can be shared, means open files in heaps. Let's just talk about files. An open file and also standard input, standard output, standard error are shared by all threads. This is the reason why when you do thread-based programming, if you put printfs here and there, you could see a mess of messages that are basically interleaved in a potentially random way. And if you are a little bit more experienced, you will always prefix maybe a message by sort of an identifier with the threads of the thread that is producing that message. So, then there is an environment block. We'll talk about that, what the environment block is. Basically, you can think of something including current directory. By the way, the current directory is one of the biggest problems the first time you are trying to develop something in Visual Studio and trying to open a file. Where is the file? So the first question is, you are trying to open maybe data.txt, and the create file always returns an error. Where is this file? And the problem is that unless you write the full path name, starting with the disk and the main directory, you are not sure because the current directory is whatever, and you have some rules for current directories. So, the environment block, for instance, includes the current directory. Then, in the bottom part of the slide, you see whatever is individual for each thread. I'm being quick on that because threads will be the topic of the next lesson, but let me just tell you that if you have n threads, where n could be 2, 3, or whatever, you have each thread that basically has its own stack. So the stack is the fundamental part of memory that is not shared by processes, by all threads in the process, but each thread has its own, because the stack is where essentially you track the execution of a program. The stack and the stack frame is whatever is allocated and deallocated whenever you call and return from a function. The stack is where local variables are. But essentially the behavior of the stack is the following. I'm calling function sort in thread 1. I'm not calling function sort in thread 2. Thread 1 is going to increase the stack by a stack frame, putting there the parameters and the local variables, working on that, upon end returning. If the function is recursive, there will be a long list of stack frames that will be allocated, whereas thread 2 is not moving. So it is natural that the stack is local storage for single threads. Then you see something that will be sort of a vague idea from now and for the rest of your experience here in Windows. So please, my suggestion is don't expect, and maybe also try to be understanding everything and try to learn everything that can be done in Windows, because it could be too much. Better to get experience with the core and stick with the examples that you've seen and try to understand and learn from those examples. So TLS is what? TLS is basically dynamic memory that I would like to access to as they were sort of global variables, global data, local to the threads. So here the situation is the following. Global variables are global and shared by threads. Stack are local variables that are by nature local, so you don't need to make them global.
What you miss here is the following. Can I have a global variable for a single thread not visible to other threads? Sometimes this could be meaningful and important. I mean, some global variable that intentionally you don't want to share with other thread. You won't be the only one simply to share a given data among different function calls or different moments in your execution of the single thread. And since the thread inherently does not have this kind of data, basically Microsoft on one side and also Linux in the POSIX on the other side have tried to implement something that worked for them. And the idea was essentially, I would make it very, very short and basic and not technical. Essentially, you have something that can create in C data that can last forever, and from the beginning to the freeing, this is allocation and pointers. The only problem with allocated memory is that you need pointers. So you will not call something a global variable, but pointer to something. So you need to keep track of pointers. And you need to store pointers somewhere. So TLS does provide you a pragmatic and interesting way of putting a sort of front end on the top of a set of pointers that have been dynamically allocated, and avoids you to call those pointers by pointers that are passed to as parameters to function, but they're seen sort of like an array of data or an array of global data. For the details, you have to look at the documentation. You will see what, not too easy to understand, but it is mainly something that will be used by the language to provide you some feature that you don't need to care about as a programmer. So here, basically, you need to know that TLS, thread local storage, is something that is dynamic memory that can be used but by a thread, sort of a global variable, global local to the thread. But it is not up to me to do with that. I will not explicitly write that in a program. My only issue will be if I write that particular declaration or instruction in my program, language support will exploit that. So it is something that is basically responsibility of Microsoft software engineers or compiler engineers. But it is simply showing you that we are closing the gap between local variables stack and global variables shared by every thread. So here you have a list, so preceding list of whatever is within a process or whatever is in a thread. And you see that a process that has more threads, virtual, code segments and data segments means that you have code, instructions, and global data, and then whatever you have more. I will pass now to the example. So this is an example of what you expect to do when working with processes. So suppose you have grep pattern and RV1 is the pattern, RV2, 3, 4, n plus 1 are the files. Here n means how many files do I want to search, do I want to grab. So what you want to do here is for I equal 1 to n included, or for I equal 0 to n excluded, up to you. I mean, for n times, I want to create a process where the process is in charge of executing the grep, single file grep command. So, here, what you need to know is what is this process doing this create process will essentially start a command, a sort of Unix command, text command, that will do grep. Grep is an executable. Another program. This program is grep mp multiprocess. The other executable is grep single process. So, single file, sorry. How can I get the results from that grep and make them available to the user? There are basically two strategies. Well, the pool programmer strategy, very well, I want to make it easy, would be the following. Grep on file, let's say everything.h, do the job, which means search and print. Grep on the second file, please search and print, which would be, as a final result, mix the lines. So, since you don't know which is the correct, well, the right interleaving of executions of the two processes, what you should expect from this poor programmer, solution would be an output that is mixing all results. And what you would like is basically not this, but this. You do not want to mix, but you would like, you want this. First, all hits from the first file, then the second file, and then the third file. You don't want to mix that. In order to do that, the solution here is the following. First, grep, do not output on the video screen on the standard output, but output on a file with a certain name. Second process, output on a file. Third process, output on a file. I, the parent process, know the names of the files once the processes, the child processes, have terminated. I will simply take the files and print them. Okay, so this is the reason why in this scheme you have, for each of the process, create a file for writing and give this file as standard output to the process that is being created. Which means that when I create 10 processes, each of them will look like a mute, well, something that is not writing on the video, but it will simply write on a file. After that, after waiting in the right way, I will simply here, for each of the 10 times, create a process that prints the file. Because I already have an executable that is doing the job, I don't want to write here instruction for opening and printing the file. So, I could have easily done file open, loop on all the lines of the file and print directly from this program, but here the solution has been, I already have written an executable, it's called cat, that is doing the job. Let's simply call that cat and do the job. Okay, so this is the reason I'm doing that. And please take a look at one subtle thing. Of course, I mean, you are supposed to be expert of synchronization, so I know I'm telling you trivial stuff. But if you look at here, the scheme for grepping, all processes grepping are running in parallel, so concurrently, because I'm creating the processes, looping on 10, for instance, process creation, and then here waiting for multiple, which would mean I'm simply waiting for all of them to finish. So grepping is concurrent, whereas catting, so printing, is not concurrent. I simply start a process, wait for that process, start another, wait, so this is sequential. Even though it is done in parallel, in concurrency with the main process. So here, whereas grabbing is concurrent to go faster, here it is not done in concurrency because we don't need to do it faster. We want to print with a given order. Okay, so this is the model. If you look at how this is done, basically we have to understand how to create a process, and this is the first part, second part, process management and handle inheritance. How do we create the process? How can I make it in such a way that the process I have created is going to take this particular file as standard output, for instance, and then I'm moving and then going back. We will have objects sharing and handle inheritance. That is sort of a little bit boring right now. It is some details on peculiar aspects of processes. What is interesting here is going to topic 4, termination and synchronization. So termination means that what you need to learn is process, exit process, and get exit code of the process that look quite similar to something that is the exit and the retrieval of the exit code or the error of a process in Unix. But you should already know that even though you do not call explicitly exit process, a process can terminate basically after the last instruction. So when the main ends, the process ends. So exit is also automatic. You will care more on how you create a process instead of caring about how I terminate the process. So exit process is basically suicide. I'm a process, I'm exiting. Whereas there is terminate process that is killing another process. Okay, so if I have the handle to another process, I can terminate it. Not suggestible, but could be done. The important thing is, how do I wait for, how do I synchronize with, if I need to wait for the termination of the process? So, there are two functions that are pretty much important in Windows because they are like handles everywhere. Whatever you have to synchronize, well, first, Windows software engineers are telling you, can I use wait for multiple objects, wait for single object? Yes, okay. Otherwise, there is something more specific. That wait for multiple and wait for single object are usable not only for processes. For instance, they will be used for semaphores, for mutexes, and for other objects that you will be using later on. Okay? So, now let's take a look at the example and let's see how does it work from the example here. Grep multiprocess. You can see that here, let's start from the beginning. You see this. Basically, you have iProcess, that is the index of the process to be created, that is iterated a certain number of times. Let's first take a look at what iProc is. It is an integer here. So you have integer and double words here. So you have this handle that is, take a look at the fact that there is one star, but there is a hidden star. Because if you look at handle, if you actually take a look at the definition of handle in Windows, you will find that the handle is a void pointer. So it is a memory address. So nothing magic. But I mean, the address is beautiful because this is the handle, which means I'm pointing to an operating system, to a kernel object. And handles are usable within the kernel, within the system interface. So, H process means I will have a dynamic array of handle. Let's look at H process, and you will see that H process will be basically a dynamic array of handles malloc and argc minus 2 number of processes times size of a handle. So you have an array of handles. Why? Because you want to start, for instance, 10 processes, and you want to store the 10 handles to those processes. So I'm probably repeating something that Professor Quer has already been telling you, but whereas in Unix, Linux, whatever you are creating in the operating system will be numbered, so files, processes have IDs, have numbers. Because essentially the operating system developers use arrays to store some different types of kernel objects and use indexes to access to those information. In Windows, essentially the software developers prefer to use pointers. And so, essentially you can have this pointer that points essentially to a struct, to a C structure, where you have all information that are required for a file, for a process, for a thread, for a semaphore, for whatever you need in the operating system. So the handle is a pointer, and since we have 10, we will have 10, for instance, processes, we need an array of 10 handles. So this array is allocated here. Then you have this process file, and process file is an array of pointers to file names. Because what we want to know here, what we want to do here is, for each process, first create that file. Now, typically, whenever we need to generate a temporary file, which means my program is producing intermediate results, not only in memory, in arrays, structure, variables, but something on file, I need to generate a name for that file. The problem with intermediate data on file is always the same. Which is a good name for my file? As soon as, whenever you are just doing little work, little stuff, you can basically name your files as you like. So, you could tell here the file name A1, A2, A3, A4. Because I think that there will be no conflicts. No conflict for one simple reason. I am the only user of this computer. And I'm working in a directory that is supposed to be clean, and I'm not producing any conflict with existing file. So, basically the responsibility of using a file name that is unique in a particular environment stands on the software developer. But there is another way to do the job, is, hey, operating system, can you give me a file name that is guaranteed to be unique? So, this is what it is done on get10 file name. So, get10 file name does the work for the idle programmer that doesn't want to generate a file name that is guaranteed not, especially for writing. Well, there are two problems if you want to use a file name. For reading, maybe if the file name is wrong or is already used, you may take the risk of reading something that is not your own file, but this is not the case here. For writing, this is a file for writing. The problem is that if you want to write on a.txt and the file already exists, there are two possible outcomes depending on the flags that you use in the create file. Either an error, because you are not allowed to overwrite the file,
Or typically, you are allowed and you will basically erase, delete the existing file. Now, it may exactly be what you wanted, because the file was a survivor from a previous run, but it may also be that you are actually deleting important data. And so, the reason why here we are using temporary file name is that we want unique file names, which has a byproduct, also a problem. If I were calling files A0.txt, A1.txt, A2.txt, I would probably not need sort of pointers to files, because names can be regenerated easily by string manipulation, essentially. Here, since I have generic names that I don't know, obtained by the operating system, I open the file, I get the name, open the file for writing, store the handle, and then use that handle for the last reading of the file. So here the work is the following: get temporary name. Get temporary name essentially is producing here a temporary file name. Proc file is a C structure. It is not a string. It is a C structure for a temporary file that includes the name. You need to look again at the list of data types and see what this kind of data is. But we have an array that is passed to where essentially we obtain a new file name, and not only. We are interested here in the name. Then you create a file for writing. So here it is simply for writing. And essentially we have a way to create the process by telling this process a startup search. Sorry, let me do this. Startup search means that this process will have as standard output and standard error this temporary file. Okay? We need to read this program in few iterations. At the first iteration, I simply try to point out some meaningful information, and then maybe more details at the next iteration of reading. So here, what we are doing is the following. We create a file name, guaranteed to be unique. Then we redirect the standard output of the new process to this file name, to this file, that is an open file, simply by storing the handle to this file name, to this file, in a proper data structure that is passed to create process. After that, I close the handle to the temporary file, and I close the handle to the thread of the newly generated process. This is so far just something to read and stop. But the important thing is the following. How do I wait for the termination of 10 processes? So here, the actual instruction I would like to write is the following. Wait for multiple objects. Wait for multiple objects. It would be enough to do that. This would be the typical way to work. So I have 10 processes. The handles to those 10 processes are written in iPros. Sorry, no, I missed something. This was the right way to do it. Okay. hpros is an array of handles to those processes. So I have 10 handles in an array. I call wait for multiple objects and pass this array to the wait function. I want to wait for those 10 guys here, those 10 processes. They are 10 argc minus 2, and infinite means that I do not want to put any timeout, and true here means I want to wait for all of them. If I put here false, it would mean just one of them is enough. So, wait for multiple objects as two variants. I have a certain amount of things to wait for. I want for all of them to complete. It's sort of a barrier, sort of. The barrier would be handled by the object themselves. The barrier is a barrier sort of used by the main process. I'm waiting for all of them. There is an alternative. For 10 times, wait for that thread. So, first wait for the first process, wait for the second, wait for the third, wait for the fourth process. So this is what I could be doing, which is what is done here at the end. Wait, it's a little bit messy, but when I look for termination for 10 times, essentially I would wait for a single object. So for a given process to terminate. Here for multiple, we are doing that. So wait for multiple objects means I pass you the array of handles, do the job, and awake me, please, when all of them have terminated. Okay, this is what I'm waiting for. There is a problem. 10 processes, okay. 20, okay. 50, okay. 60, okay. 70, not. There is a maximum number of waitable objects. That is typically 64. They don't guarantee it, but it's written everywhere, 64. Which means, what am I going to do if I, by chance, well, you need to do it, but if I wrote manually 100 file names, and I want 100 processes, how can I wait for all of them? And so this is the tricky part. And the tricky part is what was written originally. The tricky part was the following. Basically, this. Do I really need to wait for 100 things? Okay, let's first wait for all of the first 64, and then for the rest 36. So, and if they were 1,000, okay, let's group them in chunks of 64, 64, 64, 64, and the remainder. How is this done? Typically, I would do this. I would do this. Essentially, I will, for I process, starting from 0, then 64, and 64 is the 65th, actually. Then 128, and then so on and so forth. If maximum weight objects would be, for instance, 10, I would do I process 0, 10, 20, 30, and so on and so forth. Okay, so let's do, instead of for I pros equal, so plus I pros is incremented at each iteration by the exact amount of things I've been waiting for. So first iteration, let's start from process 0. So wait for multiple object will basically receive this. And you should know that this is exactly equivalent to this. Okay? Sorry. No. This. So you can go either with the name of the array or the pointer to the first slot in the array. Second time, second iteration, 64, it means that I will be waiting for the second group of processes. And then third group, and then last group, unfortunately, will not be necessarily an exact group of 64 objects. It could be less, and typically will be less, unless I would be very careful just to handle multiples of 64.
And so this is the reason, what we are basically doing here is, but this is true just for the last iteration, I will be using the minimum between
64 and the remainder. And the remainder is the current index sort of subtracted to the number of processes. So this is what we are doing. But essentially, this loop is just usable and used when we actually detach many processes. But it is there, and you will find this kind of loop in several cases. Take a look. Well, be careful, because some usages of wait for multiple processes are not difficult to find in all the exams. So these are the typical questions for an exam where we can simply ask you, did you understand? How does it work or not? And here the answer is typically clear. If you understood, the answer is right, otherwise you don't know what this for is doing. Okay, so waiting for multiple objects, since it is pretty much used everywhere in Windows, it is also a typical question for the theory part. Not guaranteed, of course.